Properties of cathode rays. Cathode rays travel in straight lines. An object is placed in the path of cathode rays where a sharp shadow is formed. It shows that the cathode rays travel in straight lines. Heating effect. When cathode rays are focused on a thin metal foil, it gets heated to incandescence. Cathode rays consist of material particles. A light paddle wheel placed in the path of the cathode ray starts rotating. Effect of electrical field. When electric field is applied to a stream of cathode rays, they get deflected towards positive plate. It shows that the cathode rays are negatively charged. Effect of magnetic field. When magnetic field is applied, the cathode rays get deflected. The direction of deflection again indicates that the cathode rays are negatively charged. Rutherfords experiment. Rutherford's experiment was found that the protons, electrons, and neutrons are the essential constituents of an atom. It was still not clear how they are arranged in various atoms. In order to find out this, Rutherford, Geiger, and Marsden studied in detail the effect of the bombardment of a thin gold foil by high-speed alpha particles. These alpha particles are positively charged helium ions obtained by a phenomenon called radioactivity. It was found that most of the alpha particles passed through the gold sheet with no change in their path, as if there were nothing to impede their movements. What was most strange was that a few of these particles only were deflected from their path. Yet, a very small number of them were deflected backwards. From this experiment, Rutherford reached the following conclusions. Most of the space inside the atom is empty. Therefore, most of the alpha particles are able to pass through the metal sheet without deflection. There is a positive center in the atom, which deflects or repels the positively charged alpha particles. Rutherford called this positively charged body nucleus. The total volume occupied by the nucleus is very, very small compared to the total volume of the atom. That is why most of the alpha particles passed through without any hindrance, while a very small number of them got deflected. Discovery of protons. Anode rays or canal rays. Goldstein, in 1886, discovered the existence of a new type of rays in the discharge tube. He used a perforated cathode in the discharge tube. On passing the electric discharge at low pressure, he observed a new type of rays streaming behind the cathode. These rays were named anode rays or canal rays. These rays consist of positively charged particles and they are called protons. Discovery of neutrons. In 1920, Rutherford predicted the existence of neutral particles called neutrons. The neutrons were discovered by James Chadwick in 1932. It is the third fundamental particle. Chadwick bombarded lighter elements like beryllium and lithium nuclei with alpha particles. As a result, neutrons were emitted from the metal. Beryllium plus helium gives carbon plus neutron. Chemical bonding. Matter around us is made up of a variety of molecules. Two or more atoms unite together to form a molecule. This union is done by the redistribution of the electrons in the outermost shell of the uniting atoms. This is called chemical bonding. Law of octet. Helium, argon, krypton, and xenon, the outermost shell of their atoms except helium, contains 8 electrons. These atoms are much stable. They almost never enter into chemical combination. So, it suggests that the presence of 8 electrons in the outermost shell makes a stable structure. Atoms combine such that they get the structure of 8 electrons of octet in their outermost shell by either transfer or sharing of electrons. This is called octet law or electronic theory of valency. This rule is applicable to all types of chemical bonds between atoms. An atom can achieve the inert gas electron arrangement in 3 ways: by losing one or more electrons, by gaining one or more electrons, and by sharing one or more electrons with another atom. Ionic or electrovalent bond. When atoms combine together, one atom may transfer one or more electrons to the other atom. In this process, each atom gets the stable octet structure in its outermost shell. This mode of bonding is called electrovalent bond or ionic bond. Ionic bond formation in NaCl molecule. Sodium chloride is a typical example for ionic bond. The electronic configuration of sodium atom is first orbit 2 electrons, second orbit 8 electrons, and the last orbit 1 electron. Chlorine atom is first orbit 2 electrons, second orbit 8 electrons, and last orbit 7 electrons. Chlorine atom needs one more electron to have the stable octet structure in the outermost shell. The sodium atom has one excess electron for the octet structure. So, in the process of combination, the sodium atom transfers its excess electron to chlorine atom. Now, the electronic configurations of sodium and chlorine atoms become 2, 8, and 2, 8, 8 respectively. Thus, both the atoms get the stable octet structure. In the process, the sodium atom loses an electron and so it becomes a positive ion called cation. The chlorine atom gets an excess electron and so it becomes a negative ion called anion. The electrostatic force of attraction between the Na and Cl minus ions keeps them together, forming a molecule of sodium chloride. An ionic or electrovalent bond is formed. Covalent bond. The covalent bond is formed by mutual sharing of electron pairs between the atoms of the same of different elements to acquire noble gas configuration. Chemical bond due to the sharing of electron pairs taking equal number of electrons from each is called a covalent bond. The force between the atoms in covalent bond is non-electrostatic in nature. Formation of oxygen molecule. The electronic configuration of oxygen atom is first orbit 2 electrons and second orbit 6 electrons. The outermost shell is short of 2 electrons to have an octet structure. Two oxygen atoms combine and form an oxygen molecule by sharing two pairs of electrons. Thus, two shared pair of electrons is formed. This is called double covalent bond.